Hello. So today's session is on the IMS Security Framework version 1.1. So welcome. This is the abstract that was posted as part of the Learning Impact Agenda. And what I'm going to go through is a background to the thinking behind the security framework, then take us on to looking at what happened in version 1.1 and provide an explanation of the process that we've got, and then give some context about how that fits into other activities that we've got within IMS, because we've learned a lot by developing, for the first time, a pattern of functional capabilities that we're going to use across several specifications. And that's an approach we'd like to adopt for other areas. And I gave a talk about the other areas of the framework documents that we're thinking about on Monday this week. But today we're looking purely at the security framework, but there is an overlap with those other framework documents. So I'm Colin Smythe, IMS Chief Architect. I've been with IMS since May 1999, worked on a lot of specifications that we've published. Those of you who are familiar with IMS know that when you look at the complete specification suite and all the various versions, there are about 100 IMS specifications currently published as active versions, and about another 20-30 that have been effectively deprecated or archived. The specifications I'm working on currently include OneRoster, open video metadata, and supporting the team looking at the new range of services for higher education and rostering. In my role as the Chief Architect, one of my particular areas of responsibility is looking at how the specifications fit together to form IMS ecosystems. And it's important to bear in context that, yes, we've got lots of specifications out there. And a few years ago, organizations were focused on perhaps adopting one specification, but now what we find is that organizations are actually adopting several specifications together. And so we're more focused on making sure that the way our specifications fit together, it makes it as easy to adopt a set of specifications as possible. And therefore, the use of common patterns as such as provided by the security framework is very important, because it stops the idiosyncrasies of various specifications as much as possible. Please, if you've got any questions, just throw them into the chat. I've got the chat open, so I'll do my best to respond, and I'll happy to take questions at any moment in time. This is being recorded, so you'll be able to go back and review it. And we've got a hard stop at 1:30, so people can get access to other sessions. Now, as is typical of IMS, we have a lot of sources of information, and these are the four areas, and it's fairly typical of any IMS specification development activity, by the way, about how we organize our work. So there's a basic entry page to the security framework documentation itself, the web there. The latest version of the document's given a link. If you want to find out as an IMS member about all the meetings that we held, and we have at least one meeting every month discussing security framework, and all the discussions about archive points on the documents and various issues that we've discussed from the members of the security committee that looks after the security framework, then go to the forum, the security forum. If you want to see the latest versions of the draft documents and any issues that have been raised with respect to the security framework, and we closed off all the issues with respect to 1.0, and we've not yet opened an issue on the 1.1, but I'm sure it's still early days, is then go to the GitHub repo. IMS has about 200 repos. To get access to the IMS repo set, you need to have a GitHub username, and then you go to the your My IMS dashboard and click on the GitHub access link, and that will take you through the process of obtaining from us access to the IMS GitHubs. Members have access to all of the forums. Non-members have access only to the public forums. So there's a lot of information there, and so this is same approach for all of the specifications. So you can always find out what the latest discussion issues are and also go back and look at the history of the development. So let's take a look now at the an overview of the security framework. So a few years ago, this will be about 2017, we'd started to do a lot of service definitions for our specifications. At that point, we'd just published the OneRoster service, which is our first REST JSON binding. We had the Learning Information Services specification went out some years earlier. And the importance there was that when we did the Learning Information Services specification, we didn't actually define a specific security architecture. And so what we ended up doing is, as part of the certification process, we had to support 5 different security approaches, including WS security, as well as basic HTTP and a few others. And whereas when we did the OneRoster specification, we actually pinned everything down onto the OAuth 10A message encryption mechanism in those days to reflect what we were doing on LTI 1.x standard, because that also used OAuth 1.0A. But what we realized is moving forward is that OAuth 1.0A is not really fit for purpose, and that we needed to make best use of all the practices out there in other domains. And so from an IMS point of view, we didn't want to create anything. We wanted to adopt and then adapt the appropriate recommendations out there for best practices, and to make those recommendations within IMS available to all the IMS specifications. So set up a set of best practices, which then the working groups responsible for developing a specification could pick and choose from. So the idea is that the security framework doesn't say this is the only way to do it. We provide a number of options to reflect the various workflows and processes that the specification is trying to realize, and therefore require the working group to pick the parts of the security framework that are relevant to them. When we took a look at our specification set, there were really 3 basic core scenarios. The first one, reflected through the OneRoster, was where you've got web service exchanges between trusted services. So providers and consumer systems, there's a well-established trust relationship. So you want to do basic web services exchange. More complicated scenario, and LTI always sets us into a different set of use cases, is where we've got the user in a browser-based environment, and we're wanting to move them from one browser-based environment into another browser-based environment without them really knowing about the transfer. And there's a lot of work to go on in the background to enable that LTI launch effectively. And then the third scenario, which comes about from our comprehensive learner record, is equivalent to the first one, except it's between systems where there is no established trust relationship. So those are currently the 3 sets of use cases that we need to cater for from the IMS specification set. There may very well be others that evolve. An example will be is that we're looking at publish and subscribe based services, and of course those really don't fit into these 3, so we'll have to think long and hard about the appropriate security architecture considerations when supporting publish and subscribe. So one thing to keep in mind is that as our specification set expands, the requirements for the security framework patterns will also be increased. So our basic architecture, looking upon the use of OAuth 2, and why? Because OAuth 2 has a very well-established footprint developed by the Internet Engineering Task Force people, and has broad adoption in many domains, and is also the building block for lots of other capabilities in authentication, such as OpenID Connect. So it was a natural point to the natural base specifications for us to make use of. And you get, therefore, from the security framework perspective, we're looking at the API definitions, or the service definitions at the top there, I, J, and K. The service definition for an IMS specification defines a and to a lesser extent X. So what we're trying to do is the fact clearly each specification defines its own API for the service between the service provider and the consumer, whereas we want to use a common set of authentication and authorization endpoint definitions at the top there. So that's a common set at the top. At the bottom is specific to the service specification. Now, one of the issues that we encounter when we're drawing together the best practices from something like the IETF and other technology domains is, of course, is their terminology is different from the terminology that we use in the EdTech community and that we in IMS use. So one of the problems and complexities that we have is to try and bring all of the different terminologies together and then to normalize them into one set of terminology that reflects the way IMS sees the world. And we do that because we're supporting IMS members and the use of the IMS specification. So it's important, therefore, that there's a terminology consistency within our specification set. That does lead to complexity when trying to map from how we phrase certain concepts into the concepts equivalent into things like OAuth2. So merely the use of the words like consumer, client, service provider adds all sorts of complexity. And so it's important that if you get confused, don't worry, everybody's confused when you try and draw together this terminology basically from three different directions. I'm not going to go too much into detail because you can read that as well as I can, and it's all written down in the relevant specification, and a bit more about it later on. So the basic transport mechanism, we're specifying the use of transport layer security, and either TLS 1.2 or the later version 1.3, which obsoletes the 1.2. But of course, there's always the delay in the migration time between when systems make these things available. The basic use of OAuth2 is defined here by RFC 6749 and 6750. And we make use of two authorization approaches there. Authorization co-grant, and that's for systems whereby there's no established trust relationship, because the basic resource owner has to give permission to a system to get access to it. And the client credentials one, which is the mechanism for the trusted relationship. And underlying all of that, we use RFC 2617, the actual mechanism to obtain the initial access token. OAuth2 is all about getting an access token so that you can actually request access to the resources that you want. And that's shown in this diagram here. So this is looking at the non-web services approach, and the terminology here is also a little bit more different because we're looking in terms of the LTI world, and LTI uses the concepts of not consumers and providers. It uses the concept of a platform and a tool. So you want to move the user who's effectively in the platform environment, and you want to move them into the tool environment. And later on, the tool itself could be a platform for other tool launches. So there could be a chain of activities going on here. So we want to make use of some way to actually authenticate that the person who wants to actually get access to the tool is the person who they say they are. So what we do in this environment here is take use of OpenID Connect, which builds upon the OAuth2 specification. And also this approach makes use of JSON Web Tokens. The general other web service approaches that we've defined, we've made it possible to use the JSON Web Token as basically as a substitute for the actual access token itself, but that's supported in the security framework, but it's not something that our web service definitions actually use. Whereas in the LTI world, it makes very heavy use of JOTs. Now, the other complexity in the LTI world, the fact is that you've got public and private key mechanisms to be supported. So you've got to look at how you actually distribute the public key information. And there's also a different perspective, depending on whether you're looking from the point of view of the platform to the tool setup or from the tool to the platform setup. Now, I'm not going to go into a lot of detail here, but the key point is that you'll see lots of identifiers littered around both of these diagrams. And it's the combination of the values and the distribution of these identifiers which is important. And on top of that, you've then got to actually distribute the public keys. And there's a variety of architectural approaches to how you actually undergo public and private key distribution. And we've not pinned down how you do the public key distribution, because we can't get consensus on what's the best approach for that. We may do later on. So there are some outer band issues still to be considered. We've got a few recommended practices now becoming dominant with respect to the public key distribution. And part of the subtlety is related to the fact that the strength of the public key needs to be protected, so you've got a good secure architecture. Because one of the motivators for moving from the use of OAuth 1.0a in the LTI days was that even though OAuth 1.0a was being deprecated by browsers, the ways in which LTI was using it was not actually vulnerable to the problems with OAuth 1.0a. So we could have kept on using OAuth 1.0a. The problem is that it gave the secret, the definition of the secret power to the tool. And unfortunately, a lot of tool manufacturers were using the word secret as their secret, and it's not very secret. And that creates great vulnerabilities. So by moving to our current approach here, actually, we've made a far more robust security architecture for the LTI world and made it more in the power of the platform to make sure that they are operating in a secure environment. Because generally speaking, it's the platform vendors who actually take responsibility for ensuring that their distribution of users is into a secure, trusted set of environments. So OpenID Connect is the heart of the LTI. So it builds upon top of OAuth 2. It adds the end user authentication, who they say they are, provides the appropriate security privacy considerations, and talks in terms of ID tokens. And the ID token is effectively a JOT, a JSON web token, as defined by those two RFCs there. The downside of this approach, by the way, is that we fuse together about 12 different RFCs to actually make this entire choreography work correctly. So we were fortunate in that the team responsible for this took a lot of advice from security experts, and we also spent a lot of time prototyping the solution. So we're very confident we've got a working solution. But it does mean that there's a far higher learning curve in adopting this framework approach for LTI compared to the old LTI 1.x. However, if you talk with the IMS technical team, we can significantly reduce the amount of time. We've also provided an extensive reference implementation for LTI, and we've got members now who can do an implementation of the LTI launch in about 8 hours worth of implementation, which is pretty impressive. And that's important from our point of view because we've reduced the complexity from point of view of our members using our reference implementation and test systems by about as much as we possibly can. So how is the framework looked after? Well, as I say, the IMS core team were not experts in security. So what we've done is pull together a representation from our members who have the expertise in security, and we combine that with the in-house technical team to create the security committee, and they're responsible for maintaining and managing, and they take ownership of the security framework document. So that means is that we've got a good basis to work from. The other responsibility for that committee is to undertake an annual security audit. And so what we're doing there is we're looking at how the security framework is being used in the set of IMS specifications, to make sure that we're doing more than just defining the framework, that we're actually ensuring that the framework is being used appropriately. So why did we do a 1.1? Well, we did a 1.1 because as our specs went through further development, we had in fact, 3 specification development activities identified weaknesses in the framework where there was omitted functionality, and those specifications were the LTI Advantage team themselves. They wanted to look at dynamic client registration to remove some of the complexities of actually getting the access credentials distributed. We had the fact that the open badge and the comprehensive learner record specification development team also wanted to look at token refresh and token revocation. The token refresh is only available as part of the authorization code grant. And none of these 3 features were actually defined in the 1.0 security framework. So we had to revise the framework by adding in the practices that the working groups identified. We documented them, made them all consistent, because you have to, again, draw together different approaches with respect to dynamic client registration, because the LTI people are making use of the OpenID Connect based dynamic client registration, which builds upon the RFC approach. And whereas for the other specifications, they were looking at dynamic client registration from the pure RFC based approach. There was one further feature that we added, which was really put together a way in which you can discover the configuration of a service provider. And we have 3 different approaches, and we've standardized on one basic approach in the security framework, and that will slowly be rolled out. The OneRoster specification is the first adopter of the service discovery approach, and it makes use of an open API based description. So the dynamic client registration, I want to get hold of the client ID and secret in an automated way, as well as provide information about the clients to some repository. And so this makes use of the RFC 7591, which generalizes those definitions. There are some features that discussed inside of there, things like software statements, which we are not recommending. There are still some issues about how do you obtain the URL for the dynamic client registration process, and that's where we make use of the service discovery document mechanism, which leads me on to this. So the service discovery document, say it's an open API version 3 JSON file description, and it's accessed using that endpoint discovery. And you'll notice that there's a, as per IMS best practices, we have a base URL string structure, which goes on top of the host name and is then concatenated with the actual endpoint discovery. So at that point, if you issue that HTTP GET request, you should be returned the JSON API 3 file description for the provider. Now, as part of our specification development process, we actually create an open API file description of the services, and we actually provide JSON and YAML versions. We felt we'd stick with JSON because it's somewhat more readable for a lot of people. So that's our service discovery approach. And say it's being used as part of the 1.2 specification, and also this enables far more ease configuration of our certification test systems, because a lot of our specifications have a lot of endpoints, and a lot of those endpoints are optional, by the way. So if you take a look at OneRoster, we've defined something like in OneRoster 1.2, there are something like 70 endpoints, of which a provider is only required to support 10, and a consumer actually could only be required to support, required to support 1 endpoint. So you could see how there's a lot of optional endpoints that providers may or may not decide to support, hence the use of the service description document to understand from a provider point of view all of the endpoints it does support. Now, even though 1.1 came out in August this year, it was 2 years after the publication of the 1.0. 1.0 came out, I think it was in July 2019. We already know There will have to be a 1.2, and the reasons for that are shown in here. Our LTI working group has got a standing issue with the fact that browsers are not permitting the use of cookies, and that the OpenID Connect process includes the use of cookies in the LTI context. So there's got to be a workaround there, and we've got to provide a migration from where we are currently to the new process. So that will have to be documented. Our Edu API working group is evaluating the use of a publish and subscribe based binding. So we'll know that when they give us the feedback in the next 12 months, if we're going to make available publish and subscribe as an optional binding, that we'll have to make sure we've addressed the security features. And that also has some difficulties, because publish and subscribe supports about 15 different protocol mechanisms. So there's going to be a lot more complexity to think about there. And then we know that OAuth 2.1 is working its way through the IETF, and there's an interesting wrinkle in there, in that the IETF has deprecated the use of the implicit method for token access request. Now, that's not a problem from IMS, because I say we only use authorization, code grant, and client credentials. However, OIDC does make use of the implicit method. So no doubt there'll be a revision on how OIDC makes use of the OAuth 2, which will have an implication on how LTI is going to make use of OIDC. So we will observe that and see what happens. Plus, who knows what's going to happen in the next couple of years with respect to security. There's all sorts of things that could happen, but that we'll have to respond to, and will require a revision of the framework document. Yeah, thank you on that, Stuart. And then to finish off, this is the set of other framework documents we're working on. And say the security framework is the one that's out and published. The other ones are works in progress. And clearly there's an interaction. So when you look down, say at the REST JSON Service API framework and the Publish Subscribe API framework, they're directly related to the issues in the security framework. And then we're looking at our privacy framework, and there's no doubt there may very well be some interaction there, where we start to look at how we address PII with respect to the specification definition, and how that's going to be impacted in terms of securing data by ensuring we're not revealing PII stuff. As I say, there'll be all sorts of other interactions between these various frameworks. There's still works in progress, the other ones, and we do expect to have a similar management process for each of those framework documents. So once it's created, the framework document will be distributed to our members for review, and then we'll put together an appropriate committee to take a look at probably all of the framework documents together at some point. And that's probably about 2 more years away before we put together that total management process for all the other framework documents. So there'll be no change to the way we actually support and maintain the security framework document. Now, we only had half an hour, so I think I've come to the end, and there is 1 minute, so plenty of time for any questions if anyone wants to put it. I say this has been recorded, so the links to the recordings will be made available in a couple of weeks. If not, thank you very much, and keep safe.